Cześć wszystkim. Nazywam się Radomir Dopieralski, pewnie część z was już mnie zna. Pracuję w firmie takiej mało znanej, nazywa się Red Hat. I pracuję nad projektem, który też jest mało znany, nazywa się OpenStack. I postanowiłem, że tym razem nie będę dawał wam wiedzy konkretnej, tylko że dam wam tak bardziej motywację może. Spróbuję tego... Tak w ogóle to właśnie sobie przypomniałem, że powinienem mówić po angielsku, więc będę mówić po angielsku. Sorry. My name is Radomir Dopieralski, I work at Red Hat on OpenStack, and I'm going to motivate you. I'm going to motivate you to be more professional programmers, to work more professionally on your projects. Not necessarily when you program at work, when you are programming as a hobby, it's also sometimes good to be more professional. What does professional mean? For me, at least, it means that for every case that you get, you are not picking and choosing them. You just get a task. And together with your team, not just alone, but together, you quickly find the solution to the root cause, to the root problem, and not to the root problem of yours, to the root problem of your client, because there is a huge difference sometimes, in a way that is easy to maintain later on, and in a way that doesn't introduce additional technical depth. Disclaimer, I'm not a professional programmer. This is not something that I'm a professional programmer, now I'm going to tell you how to become more like me. Not at all. This is an ideal. So this is some abstract, imagined person that is perfect in every way. And it doesn't really exist in reality. But you can use it to ask yourself, what would a professional programmer do, right? In a situation to help you with amending your approach to certain problems. And also, it's not appropriate in all situations. I'm not trying to say that you should behave professionally at all times, or even if it's a good thing to behave professionally. You always have to decide when it's more appropriate or not. So that's about the disclaimer. I'm also not going to actually tell you much about your attitude or psychology or things like that, because I basically don't know anything about that. I go by a gut feeling on that. But what I can tell you about is about the tools that professional programmers use, and the tools that make it easier for you to behave professionally. So tools that make your work easier and make it nicer for your clients to cooperate with you. Well, the very first thing that you need to do when you are starting a new project, start a new repository for a version control. If you are not using a version control, you are not really programming anything. You are just toying with the language. That's not making a project. You need version control, and it also changes the way that you code. It changes the way that you think about your code, because it forces you to work at one change at a time, right? One atomic change that you are going to commit. So you are not like changing a million things at once, and also you need to focus more on think about what you actually want to achieve. That changes a lot in the way you are programming. If you need to work on several things at once, you can use branches, or you can clone the same repository several times, depending on what is the best practice for your team. Another thing that version control changes, you are not afraid of removing code entirely or rewriting a part of code, because you can always go back to the earlier version that worked. So you are not more afraid of making your program better. This obstacle is removed. That's a great thing. You can also easily find, when you find that something became broken some time ago and you are not sure what caused that, there are tools in the version control systems like the bisect plugin that let you find that out very easily and point to the exact commit that introduced the problem. So why not use that? And the last thing, commit often. Commit practically every time you finish some small change, and push at least daily, and basically push when you finish a single change. When you are confident that it's good enough to be reviewed by your team. Second thing, of course, test-driven development and so on. If you are programming in a dynamic language like Python or JavaScript or whatever, and you are not writing tests, then you don't really know if your program is actually working. You may have typos in there. You can have, I don't know, really code that has no right to work in there. And you will never know until it gets to production if you don't run tests. So you have to have tests. Also, the tests change the way you are programming. Because, again, if you know that you have to write tests for that, you are going to divide your program into independent units that you can test easily. And that's better architecture. That actually forcing you to write tests makes your architecture better. Makes your code more reusable because you have independent units, it's easier to reuse them, and so on. Yes, if you have tests, if you have decent coverage of your program, you are also not afraid to improve your program. Because you know, oh, I can rewrite this part, and if I broke something, if this optimization doesn't really do what I want, the tests will show me. So that's so much easier. And finally, debugging. Often you would insert some print statements in your code or somehow, I don't know, change something, reference the web page, change something, reference the web page. And if you have tests, if you just write the test for the bug that you are trying to fix or the feature that you want to appear in there, you can just run the test and see how it's working. It's so much easier to check your progress, check your work when you are debugging with tests. Also, when instead of inserting those print statements in there to check if the state of the program is what you think it is at that point, just write a test that checks that. The plus side, the work is the same, basically, and the plus side is that this will execute every time, and this will catch your mistakes later on. So, very, very nice way. Also, when you are write regression tests. So when you are fixing a bug, write a test for it, so that you make sure that bug will never ever again appear. It will never come back because you have a test for it now. Next thing, use a backtracker. A backtracker is useful not just for your clients. Actually, I'm not even sure if your client should have access to your own backtracker, like the working one. It lets you plan your work, so it also ties in with this, change the way that you are writing code, because now you are planning ahead what you are going to add and in what order you are going to add that. So you can plan your work. You can share this plan of yours with other people in your team and with your client to make sure that what you are going to do is actually what they want. You don't have to leave to-dos in your code anymore. So that the code looks like it's finished, and it should work until you look into the source code actually, and you see there are lots of to-dos in there. Instead, put that all into the backtracker, and then you can see in what state your code actually is. You can track your technical debt in this way. Yeah, when you are closing a bug, link to the commit that actually has the fix, because later on you will want to go back to that at some point. For example, when a similar book appears and you want to check if the fix, if someone, for example, broke the fix that you made or something like that, you want to keep the history. And when you are closing the bug, don't just click on the close. Explain what actually was wrong. It can be just a single sentence. It can save your life later on when you hit that problem again. Linter. Linter is a, how to say it, a tool that checks your syntax, that checks your style. And first of all, it will check simple errors like typos, like, I don't know, unused variables, unused imports, stuff like that. And it's really handy to have it connected to your text editor, for example, to just highlight all the errors in real time for you. Then you can concentrate on the actual important errors. It can also make your code easier to read because it will force you to comply with the style that you are using. And so you no longer have, I don't know, spaces at the end of lines or some strange indentations if it's not Python but something else, and so on. And finally, it will enforce style, and this is actually very important if you are working in a team and if you are working on very large code base like OpenStack, to have consistent style throughout all of the project. Because good programmers program using their good gut feelings. Good programmers don't just think with their conscious mind, they also think with their unconscious. They get code smells, like, I don't know what's wrong with this code, but it smells to me. It's something fishy in there. And to do that, you have to have consistent style. Otherwise, code that is perfectly fine, but is just formatted in a strange way, would smell already, right? You would already be suspicious. And you don't want to waste time on that. So if you have consistent style, it's much easier to spot actual errors, actual difficult areas in your code. Yeah, so how to come up with the style that you are going to use. So avoid constructs that are error prone. So avoid things that require you to be careful. Like JavaScript has a lot of those traps, and Douglas Crockford came up with a subset of it that you can use for programming, but you are avoiding most of the traps that way. Python also has a couple of those traps. For instance, if you have an empty tuple, who knows how to write an empty tuple in Python? Okay? Oh? Yeah, and if you just put brackets and no comma, it's still, but single element tuple then. How to write a single element tuple? Yeah, and if you just have brackets and one inside, that's just one, right, in brackets. That's one, it's not a tuple. That's why we usually, when we have some value that takes a tuple, like a list of names or something like that, even if it only has one element in it, we put it on a new line and put the brackets on new lines. This way you see it's a tuple and it has a comma at the end of the line. This way when you are adding or removing elements, even if you are removing elements and just leave one, you still leave the comma there. It's still a tuple and it doesn't become something else. Things like that let you avoid errors. Another thing, don't use abbreviations for your variables unless it's some very common abbreviation that is agreed by everyone, like HTTP, right? Don't spell out hypertext transport something protocol. HTTP is fine, right? But don't make up abbreviations on your own. Don't, I don't know, use the beginning of the word only because that's faster to type. You are going to type that once, but you are going to read that many, many, many times. So optimize for readability. Try to conform to the style that is most common for the language that you are using, because then you don't have problems with libraries, you don't have problems with, I don't know, posting code on forums and so on. Yeah, and broken windows, right? There is this social experiment in Detroit, I think they made. They were looking at a car that was left on the side of the street, like a derelict car. And they noticed that it's fine, nobody damages it, nobody vandalizes it too much, until there is a broken window in it. As soon as one of the windows is broken, the car is like put apart by vandals in like one day. So it's very important to fix broken windows in your code, like fix the things that look bad in your code, because if you do that, people will care more about the looks of the code generally. If you open a source file in editor and you see that this is a total mess, you don't feel bad for adding more mess to that, right? And if you see it's perfectly formatted, clean, beautiful code, you will add more work to actually keep it that way. So, documentation. Use things. If you are writing in Python, just use things. Learn the restructured text format and the additional things for things. This is really great, and this is the best tool for documentation in Python. Learn English and write your documentation in English. Unless your clients really require you to deliver your documentation in Polish or some other language, English documentation, even if you don't have any English-speaking, non-Polish speakers on your team, you are going to have some sooner or later. Or you are going to need some consultants, or you are going to need someone to look at it. English is the lingua franca of our profession, and reading documentation in English, sorry, you have to learn it. Write whole sentences, and write whole sentences also in comments, and also in commits, and everything else, because that will make them easier to understand out of the context. It's not so much work. Start with a capital letter and with a period. Check spelling. I have a spell checker connected next to my linter in my editor. It checks spelling in my comments. It's similar to those broken Windows things. If the spelling is wrong, it doesn't look very nice. And one cool thing that Sphinx has as a plugin that you can enable, you can write the examples of use of your functions and so on as doc strings, and Sphinx can pull them out of your documentation and run tests on them and check that they are actually really working. And that means that if you make some change in your code that changes how the documentation should be written, you will get an error and you will have to fix the documentation. So it's easier to keep documentation in sync with your API this way. Code review. This is a very important thing, and right now I can't imagine working without code review. I can't imagine writing some code and just pushing it to production without anybody else looking at it. And yeah, there are very big advantages for that. The first and most important one is you are all learning from each other. The person who is reading code written by a very good programmer is picking up good habits from reading that code. The good programmer reviewing code written by worse programmers, by newbies, can point out problems with their approach and can show them how to make things better. It's the best tool for learning. And it's the fastest way to learn language. Just doing reviews and doing pair programming. Because you are reviewing code, there is no more, I will fix that thing later, let's keep it like a dirty hack. And later on, I will maybe come back to it, because you are never going to come back to it. Don't cheat yourself. And if there is a review, and you know that that person will catch this, you will just not write it in the first place, right? You will write it the right way from the start. By doing review, you are also keeping track of what is going on in your project. So if there is only one person working on a certain module in your project, and that person gets hit by the bus, you have bus factor of 1, right? It's actually a term for that, the bus factors. How many people in your team have to get sick to completely stop your project? And if you have bus factor of 1, this is going to happen sooner or later, right? And if you have code review, at least one other person is looking at that code, so has some idea of what is happening. And if you are doing code review properly, several people are reviewing. And that makes all the people in the team informed of what is going on in the project. Also, you can have meaningful technical discussions because you have code in front of you. You are not standing by a white table and discussing some, I don't know, astronomical, architectural, general ideas. You have code right there, and you can point to the lines of the code and have like real grounded arguments about that. And if somebody doesn't believe you, you can pull out this code, put it in a short program, and show them that it really works like you are saying it does. Okay, external libraries. There is this bad thing about teaching at the universities that they tell you, you have to write all your code. You can't use any libraries. At least in the first classes, like the programming 101, they tell you, okay, you are not going to use, you have to know how this works, so you are going to write everything from scratch. This is fine for learning, but this is a very bad habit for work. You should not reinvent the wheel. Even if the library that you are going to use does much more than you need, that's even better, because you are going to need more sooner or later. And then you already have that in the library. Like, people don't like Twisted because it has everything in it. So because Twisted has too much in it, they are implementing stuff like DNS themselves. What sense does it make? It's fine that it does more than you need. Don't use the extra part. It doesn't cost you anything. Also, when you are implementing your code, divide it into libraries. Make it libraries. If you are working with libraries from the start, you are familiar with working with libraries. You are also familiar with how to make your own library, and you can compose your program out of libraries this way. It will be better. And finally, when you find a bug, and you find out the reason for that bug is in some library, don't implement a workaround. Don't patch it locally on your computer. Fix it upstream. Send it to contact the people who made that library. Usually they are very responsive. If they are not, you can even fork the project and then make the fix there. But don't fix it just for you, because sooner or later you are going to need to upgrade that library, for example. And what? You are going to reintroduce all the fixes that you made into it. And sure, you can make a workaround for now, and at the same time send a patch to the upstream remove the workaround when they fix it. Put a URL to the bug in their bug tracker in your code, in the comment there, telling, or even report a bug in your bug tracker to remove that when they merged it. So that, you know, you don't have, your program is not a pile of hacks. Packaging. When you are making a program, make it available for everybody and make it available properly. So have setup.py so that your library can be installed, your program can be installed. Provide a sane version number. Sane, by sane I mean at least monotonous, so growing, not, I don't know, some random numbers of, I don't know, consecutive digits of the pi or whatever. Sane, growing version number, so that people who use your software can actually say, okay, this was fixed in this, so I need the version at least that. Provide a license with your program. If you make it available anywhere, on GitHub, on your own repository, on your web page, provide a license. Because people are going, okay, you may say, it's not that serious, it's just a small snippet. Even if it's a small snippet, and you don't care about license, say it's public domain, so that people can safely take it and use it. Because by default, you cannot use codes from the internet. That's the law. If there is no license, you cannot use it. Provide a contact so that people can fix your bugs, for example, when they find it. Or that people can ask you for the license if you forgot to include it, or for whatever reason. It doesn't have to be your main email. It may be an email that you check once a month, whatever, but some way of contacting you, it's very important. And yeah, you can fill all the other package metadata in setup.py, and if you have time for that, do it, please. It will make life easier for people searching the PyPI and also doing statistics and stuff like that. And that's all. Any questions?
Hi. So speaking of code review, apart from GitHub's pull requests feature, are there any tools you would recommend?
The question is, are there any tools for code review? I know, apart from GitHub and Bitbucket and so on, I know of two of them. We are using Gerrit in OpenStack, and it sucks really bad. But yes, we are using quite old version of Gerrit, and it's been hacked a little for our purposes and so on. It's better than nothing. It's much better than nothing, actually. And you can do code reviews with pen and paper, or do daily meetings in your office and do code review on the projector or whatever. It really doesn't matter how. You can send them by email. Linux kernel does that by email. Still. I mean, kernel, it's a huge project, right? It works for them. It doesn't matter what you use, as long as you are doing it. And the second one I've used very briefly, so I can't really comment on it, is a review board. So there are many of them. If you look for those tools, just pick anything and just use it.
Okay, thank you.
Anybody else? Don't be shy. Comments, doesn't have to be a question.
On one of the slides you said don't increase technical debt.
Yeah.
Could you recommend any tool which says about technical debt?
Since technical debt is a very fuzzy concept. It's like a very philosophical thing. You cannot really measure it. It's like more like a feeling about the. On the other hand, Backtracker is a very good tool for tracking your technical debt, as long as you are not lying in it. All the Scrum tools, or actually all the methodologies for project management, one of the main purposes of those methodologies is tracking technical debt via some proxy variables that are easy to understand. But yeah, there is also one thing that I've seen several times when a new manager comes to a project. One thing he says, okay, bring out all of your skeletons from the closets. Tell me about all the things that you know are broken, but you were afraid to admit it or say it. Or just don't be cruel to me. Don't I don't know how to say it in English. Owijać w bawełnę. Yeah, just tell me straight what is wrong with this project, so that we can do something about that. And having something like that once in a while, because if you have it all the time, people will stop believing in that, right? They will still hide stuff that is kind of, they don't want, they are shy, they are, how to say it? Yeah, they don't want to tell bad news, right? Encouraging people for telling bad news is also very nice practice. But generally, there is no general way of tracking technical debt or expressing it.
I used one tool. It's a Sonar Cube. Sonar Cube, it's have a plugin for Python, and it checks some. It's a static code analyzer which shows tries to find the technical depths.
Well, it tells you about your code. It doesn't tell you about your project, for example, or I don't know, architecture or stuff like that. There is also this thing that was supposed to measure quality of packages on PyPI, that cheesecake thing. There are all sorts of. There is Clone Digger that tells you how much of your code is repeating all over the place. Yeah, but those don't really tell you directly about technical debt. They just tell you. Yep.
How about a long line files? How separate? How long line files it's too long.
So your project has to have a style guide, and you have to check in the style guide for your project. If you don't have the style guide, you have to get together with your team and agree on a style guide, and agree what you think is the best line length, and stick to that. There is no one global best thing for all projects in the world. Each time for each particular project you have to agree. It's nice to stick to the defaults in the language, and Python has this PEP8 thing where they specify that the optimal line length is 80 characters, up to 100 if breaking that line at this point would make the code harder to read. But really, the whole PEP8 is also just a guideline. So you should have your own style guide in your project, and then you agree on certain. You also agree on other things, not just line length, right?
Just maybe another question. You made a lot of code reviews for Horizon, right? And what do you think? How many % of contributors follows those rules? Is it
well,
quite common, or
they have to follow? I mean, the rules of general professional programmer. Nobody follows those rules all the time. That's impossible. It's an ideal, as I said. It's some imagined perfect person. Nobody follows that all the time. Then again, if you have code reviews, if you have people watching your hands, if you have bugs where you have described things and people are talking to you, you try to behave better, right? So you are trying to
So maybe a little
maintain
bit.
appearances.
Yeah. So maybe a little bit different. How often there is somebody that is sends some patch which it completely sucks?
Every time somebody sends a patch, it starts off completely sucking. That's why we have code review and we have comments and we have repeatedly, the person is repeatedly submitting new patches with the problems corrected. And I don't know if we even have any patch that was merged without any comments, maybe some typos or something like that. Usually there is always something you have to, you can improve, right? We have changed the message when you -1 patch. It used to be, I would prefer you don't merge that. And we now changed that to this patch needs more work. This is much better for review because it communicates better how it works. Almost nobody gets it perfect the first time. Even if they are contributing for quite a lot of time and already know the rules, there is always something in there. So it's not really a shameful thing to submit a patch and have someone comment on it and show you some trouble with that. Okay, thank you very much.